Welcome to Algebra 2, Semester 1, Unit 5, Final Exam Review Guide. I'm really proud of you guys if you've managed to work through 1, 2, 3, and 4. We've just got 2 more little packets here to go through. Again, I'll meet you at Starbucks sometime soon, as it can work for us for a tutoring session. But until then, continue to Google and search things out and really struggle with these. Remember, that's how your brain really learns, is when you struggle a little bit. So right now we're given the situation where we're given 3 points on a parabola and we're asked to find the equation. But if you notice, they aren't going to have us find the equation on this one. They're simply going to give the 3 equations that can help us to find the quadratic function. So remember from when we were doing this in class, we think of standard form ax squared plus bx plus c equals y. That's just your standard form of a function. Now we have the x and we have the y. Plug them in. So we have a. Take your x squared, we're going to set it in the front. We always like the numbers in front of the letters, so 1 squared plus bx, and again the x is 1, so it's 1b. We're just plugging the x in right there. I switched the order. Plus c equals, the y value is -3. Simplify this, 1 squared is 1a. Plus 1b plus c equals -3. Now, I like you to stop at that point on a multiple choice test and eliminate wrong answers, because we know this is our first equation that we'd use. When we look at the answers, well, this one has x's and y's in it. Right away, we can say, well, that's not going to work because we're substituting for x's and y's. This one also has a y in it. So those are out on account of that. Now when we look at our next option, the only difference in these 2 options is that this a has a 2. This one has a 1. The one that matches ours is right here. This one's out because of the 2a. Please mark what's wrong with them. I want to make sure that you're practicing your critical analysis. Let's go ahead and do the next equation just to verify that this looks right. So again, we have a, the x is squared, so 4 squared is 16, plus bx, so it would be 4b, x is 4, plus c equals 6. When we come down and we look, it looks identical to what we've just written. We can say, yeah, confidently, we're sure that that one is correct. Number 38. Again, look at your answer options on these kind. They're wanting us to fill in what would be right here. We can see we're going to go from 16 down to 4. Well, what do you divide 16 by to get to 4? This would have to have a 4 right here. On that alone, you should go to your answers and look at which ones have a 4 in the front. We only have 2 options with a 4 in the front. This one has a 64, it's out. This one has a 12, it's out. The next thing we go to, well, this goes from x to the 4th to x to the 3rd. That x to the 4th means that there's 4 x's on top, but we end up with only 3 x's when it says x to the 3rd. We need to wipe one out, so there has to be at least 1 x down there. I shouldn't say at least, there has to be exactly 1 x down there. So we put an x there. Let's go to our x terms. This is 7 x's, this is 1 x. So obviously that's the problem there. And there's our correct answer. Double check with the y. Y to the -3rd down here would get moved to the top to become positive. And 7 plus 3 is 10. So that one verifies. Excellent work. Make sure to be pausing this video. I'm just kind of pushing through so that my tape time doesn't take too long to upload onto YouTube. So pause and go backwards. When we get to this problem, We look at the very innermost, we have a negative exponent. We need to make that positive. Please go back to Unit 3 and look at the notes if this is moving too fast for you. To make a negative exponent positive, we write it on the bottom. And now we've got the same thing as what's in here, written this way with all positive exponents. Next, we bring in the -6 there. Ooh, that's a negative exponent. Again, to make that a positive, we need to flip all items inside the parentheses, top to bottom, in order to switch this sign to a +6. Now, we'll be multiplying. We know on top we're going to have c to the 18th. Let's stop right there. See if we can eliminate some answers. This one has c on the bottom, it's out. This one it's c to the 3rd. That's the only part that's making it bad. That one's c to the 18th. That might potentially be our answer. Oh, that one is our answer. This one they have c on the bottom. Okay. Next problem. I want to find the perimeter. Remember, rim means you add it up the whole way around. So we're going to have two widths, 3x minus 2y, 3x minus 2y. Do not add your exponents when you're adding. So it'll be 6x minus 4y. Now we're going to have two of these lengths as well. So let's take 2x squared plus 2x squared. That would be 4x squared. An x plus an x would be 2x. A y plus a y would be 2y. So we have 4x squared. 6x plus 2x would be 8x. Positive 8x. And a positive 2 minus 4y would be a negative 2y. You can see here, they almost had it right, but they put the wrong exponent. Here our lead one is cubed. The whole thing's out on that one. These two have the right exponents, but only one of them has the addition of all the parts. This one has a 2 there, it should be a 4. Okay? Down to 41. Which expression must be subtracted from this to result in that? Well, let's talk about subtraction for a minute. If I subtract from 5 and the result is 3, what did I subtract? 2. Look at this relationship. Can't you just add 2 plus 3 to get 5? Okay, so if I'm saying that I'm going to subtract it from this, 4x squared minus 6x plus 2, I'm going to subtract something, and I'm going to end up with 5x squared minus 9x minus 3. So let me erase that. Get it out of our space there. This is just like the simpler subtraction problem. I'm just saying, well, these two must add to equal that. So what could I add to 5x squared and end up getting 4x squared? If you said a -1, you're exactly right. Has to be a -1x squared. Okay, I'm adding again. So has to be one of these two, -x squared. Can't be that one. So that's a 9. Can't be that one. It's an x squared. Okay. We have a minus 9x. What can we add to -9x to get -6x? If you said +3, because you'd be actually finding the difference where they have opposite signs, that would result in 6. then you are exactly right. And this would be our answer choice. Not this one, it has 15. Okay? Find the product. Well, let me go to something a little bit simpler. 2 times 3 times 4. You can't multiply everything all at once. 2 times 3 is 6, and then you multiply by 4 equals 24. Here, same thing. You've got a FOIL x plus 1, and you could FOIL either way. I always just go left to right. X plus 5. So we get, whoops, that's not it. X plus 1, it's x minus 1. I apologize. So x times x would be x squared. Negative 1 times x is negative 1x plus 5x minus 5. Combine your middle terms, x squared plus 4x minus 5. Now we're going to multiply that by our x minus 3. When you do this, you can't really do FOIL, but the important thing to realize from FOIL is that you are making sure that each of your terms from one to the other were being multiplied by the other terms. So you just have to be systematic. X squared times x would be x cubed. X squared times negative 3, negative 3x squared. 4x times x would be 4x squared. 4x times negative 3 would be a negative 12x. Negative 5 times x is negative 5x. Negative 5 times 3 is positive 15. Well, we can tell on the ends we're going to have an x cubed and a positive 15. So let's look at our answers and see if we can eliminate anything. X cubed, positive 15 and D is good, but x cubed and negative 15 doesn't work for us. All the others have those, so let's continue forward. 4x squared is positive, 3x squared is negative, so we subtract, find the difference, and give the sign of the larger. So it's x squared. This one's out, it's got a 7x squared. This one's out, it has no x. That one's it, has an x squared. Go ahead and finish. Both negatives become more negative, 17x. You add them together when the signs are the same. Okay, verifies that it's B. Next one, you're going to have to do a massive box or a FOIL. I'm going to show the box just because I have a lot of you that like to do it still. 2x squared plus 4x minus 5. We have negative x squared plus 3x plus 6. So negative times 2 would be a negative 2. X squared times x squared is x to the 4th. Negative x squared times 4x would be a negative 4. X cubed, add your exponents. Negative x squared times negative 5 is a positive 5x squared. 3x times 2x squared is 6x cubed. 3x times 4x is 12x squared. 3x times negative 5 is negative 15x. 6 times 2x squared is 12x squared. 6 times 4x is 24x. 6 times negative 5 is negative 30. Okay? So, one trick to remember on these boxes is if you're going to have like terms, they're usually diagonal if you've had them in standard form. The first term stands alone. There's nothing like it. The next term, 6x cubed minus 4x cubed, would be positive 2x cubed. Let's see if we can eliminate just from that much. This one has the negative 2x fourth, but has 24, it's out. Negative 2x to the fourth, but has a positive 9, it's out. Negative 2x doesn't even have negative 2x to the fourth. That leaves us with that answer. Now on your test, I would hope that you'd go ahead and finish getting these off here. Remember, you'll have 3 terms to combine on that one, 2 here, and then a single one out there. Okay, next one. Factor completely. X to the fourth minus 13x squared plus 36. This should be the x game. You want it to add to be negative 13, multiplies to 36. And since this is positive, I know the signs are the same. Since this is negative, I know the signs are negative. Okay? I think of all my factors of 36. Break it down, 6 and 6, 2 and 3. And I rearrange them until I have something that would add to be 13. If I went 6 and 6, that's 12. That's close. Let me go with those. That would be 12 times 3. That would be 15. We could switch and put the 3's together. Let's go 2 and 2. And 3 times 3. That would be 4 and 9. And that would work. So I put 4, 9. Don't forget to bring down your middle variable. Now you can go to 4 term or you can take the shortcut because there is a 1 right here. Taking the shortcut would have you do this. It would be x to the fourth. I'm sorry. I wouldn't recommend the shortcut only because we haven't done that many with x to the fourth. That would have been x squared, but let's go back. I'm a little bit worried some of you all get lost there. Let's go x to the fourth minus 4x squared minus 9x squared plus 36. Take what we can out of these two. That would be an x squared. We would get x squared out to the front, x squared minus 4 in here, x squared minus 4 in here. That would bring down a negative 9. So our factors are x squared minus 4 times x squared minus 9. Now, if you got that far, what you're going to start to realize is, oh, I don't have any answers that match. Luckily, they put that one there, because otherwise you might have been more fooled. When it says factor completely, even if I put a negative there, you should know these are a difference of 2 squares. You've got to go further. So in doing that, we say difference of 2 squares. Oh yeah, that's the minus plus situation. We have x plus 2, x minus 2. This one is also a difference of 2 squares, x minus 3, x plus 3. And you can find this right up here at D. Okay? Identify what's wrong with the others here. They didn't break that down to 2's. And here they have x plus 2 squared. So those were incorrect. Factor completely. Now, when you do this, there is a poster in the room that would help you. If you don't happen to notice the poster, then you might notice the reference sheet that comes with the test. Okay? This is a difference of perfect cubes. You were to memorize the perfect cubes before, so you would know that this is 4x cubed minus 3 cubed. Okay? Now, on the reference sheet, see the minus? That is your formula. You need to use it. We said that 4x cubed was subtracting 3 cubed. So everywhere you see an A, you put 4x. And everywhere you see a B, you put 3. And we'll get into more of what this means and how to do this without following the formula At another time, we've got a good little sing-song with it. So this would be 3 times 4x plus 3 squared. Simplify those later terms, 4x minus 3 and 16x squared plus 12x plus 9. We should find that answer. 4x minus 3 happens for all of these. Next up, we have the 16x squared plus 12x plus 9. 16x squared plus 12x plus 9 is right there. This one, they forgot to square the 4, forgot to square the 4, and here they've brought in negatives. Okay? Really be aware of your formula. Okay, solve. On this one, we need to factor in order to solve. So we factor out the m's from all of these. That would leave us with m, 3m squared, minus 2m, minus 5 equals 0. And we ask ourselves, what would multiply to be negative 15 and add to be negative 2? One has to be negative, one has to be positive to be a negative. And my factors would be 5 and 3. Bring down the m. Now I'm going to have to skip down below it to show the rest of that. We're converting to 4 term. Ignore this guy out here, he'll come into our answer. We use the old man glasses, as you guys call them. 3m squared minus 5m plus 3m minus 5 equals 0. Okay? Underline the first two. M will come out of those. So we have m times 3m minus 5. 3m minus 5. So it's plus 1. So our final factors are m, 3m minus 5, and m plus 1 equals 0. You want to set each of these to 0. So the first one, you know, m will equal 0. Are there any answers without m being equal to 0? No, we can't eliminate anything there. So now we have m plus 1 equals 0. M plus 1 equals 0. Solve for that. That would mean that m equals negative 1. Well, hopefully we have some we can eliminate there. M negative 1. There's no m negative 1 here. It's out. Okay. M negative 1 here. There's nothing there. And m, we're done right there. We don't even have to go to the last one. Now you can, just to make sure that it fits. Especially under testing circumstances, if you're not timed, take that time to double check it. Okay, next one, we're supposed to solve this one. Again, it has a middle term, so we're going to end up bringing it, setting it to 0, and bringing it over to play the x game. So x to the fourth minus 3x squared minus 10 equals 0. You just subtract 10 on each side to eliminate it over there. Negative 10 down here. What multiplies to be negative 10? Adds to be negative 3. That would be a negative 5 and a positive 2. Bring down that exponent, variable and exponent, because you are converting from 3 term to 4 term with the old man glasses. So you have to replace the middle term with these. That's why you use its variable. Okay, we now have x to the fourth minus 5x squared plus 2x squared minus 10 equals 0. We take out an x squared. We'd have x squared times x squared minus 5. Over on this side, we copy paste x squared minus 5. And we find what we're missing is a plus 2 equals 0. So now we have, as our solutions, I guess I could put them right here, x squared minus 5 times x squared plus 2 equals 0. Set each of these to 0, x squared minus 5 equals 0, and x squared plus 2 equals 0. X squared equals 5. X equals plus or minus square root 5. This one's out. There's no square root on that 5. This one's out. There's no square root on the 5. That one looks good. That one looks good. Let's go on to the 2. X squared equals negative 2. We take the square root. And remember, we always get the negative out as I, so it's x equals plus or minus I square root 2. This is the only one with the I. This one is missing the I. So that's my answer. Okay. Next one. I like these without the middle term. They're a lot faster. So we add 36 to each side. We have x to the 4th equals 36. We take the 4th root of 36 and we would come out with x equals 4th root. No, I'm sorry. You know what? I don't like how that worked out. Because it is the 4th root of 36, but you aren't going to find a 4th root here. And it's plus or minus. So what I would back up and do, it's kind of good that I did this so that you can see what I would do in a test when I came to that. I would back up and say that's a difference of 2 squares. X squared minus 6 times x squared plus 6. And then I'd solve each of those. X squared equals 6. X squared equals negative 6. Now I take the square root of each side, so x equals plus or minus square root 6. X equals plus or minus I square root 6. Okay? Ask me in class if that one confused you a little bit. It would be possible to explain this, but I think it's easier knowing the knowledge that we have to go back to this, and it just makes more sense. So here we don't have a square root symbol on that. That one's out. Here, that looks pretty good. Let's look here. Oh, we don't have square roots on these. Don't have a square root there. There's our answer option. Okay. Next up, we have one way to factor x6 plus x cubed minus 72 is to rewrite the expression. What is equivalent to b? Okay. In doing that, we've just done this a little bit in class, but it's kind of like what we do with the cubic factoring that I told you is we want to take x to the 6th and make it equal to a square. So what could we be multiplying this by, this 2 by to get to 6? That would be cubed. Okay? In doing that, we're saying that b is equal to x cubed. And that's how come you would have just a b in the center for the x cubed. So that's your answer. That brings us to the end of Unit 5, review for the final. We just have one more unit to go through. Thank you very much.